The other day, Cloudflare had a very large-scale outage, lasting a total around 6 hours. This, I'm not sure on the exact scale. My understanding, though, is basically everything. If it was behind Cloudflare, you just couldn't access it. Now, this is not the first time Cloudflare has had an outage. 2022, 2023, 2024, let alone an outage this year. However, as this one is following a blog post about the introduction of Rust into their development workflow, and the specific code block in question that caused the problem is written in Rust, the usual suspects have come out to start raving about how this is a fault in Rust and this was caused by the Rust language, rather than what actually happened, which is a dev pushing buggy code to production. I am not going to convince any of the people that want Rust to be part of their culture war bullshit of what actually happened. But to the rest of you, I hope to leave you better informed about what actually happened here. On the 18th of November 2025 at 11:20 UTC, the outage began. Now, I actually had a podcast scheduled about 10 minutes after this on Jitsi, and Jitsi is behind Cloudflare. Thankfully, other things not behind Cloudflare exist. The issue was not caused directly or indirectly by a cyber attack or malicious activity of any kind. It was triggered by a change to one of our database system's permissions, which caused the database to output multiple entries into a feature file used by our bot management system. That feature file, in turn, doubled in size. The larger than expected feature file was then propagated to all the machines that make up our network. As we progress, we'll get more into what that actually means. Now, initially, because of the symptoms, they actually thought it was a wide-scale DDoS attack on Cloudflare, which has previously happened. That's not what happened here. This chart here shows the volume of 5xx error HTTP status codes. Normally, it's pretty low. Obviously, there's going to be some level of error. Any sort of network service is going to have this. This is where everything began. But the spikes looked really weird, and the spikes are why they thought it might have been a DDoS. Usually a DDoS is going to come in waves. When you have an error on your actual system, it's typically just going to go out and not come back, go out, come back, go out. That doesn't make any sense, or at least it didn't initially. The spike and subsequent fluctuations show our system failing due to loading the incorrect feature file. What's notable is that our system would then recover for a period. This was very unusual behavior for an internal error, but it made perfect sense. The explanation was that the file that was a faulty file was being generated every 5 minutes by a query running on our ClickHouse database cluster. Bad data was only generated if the query ran on a part of this cluster which had been updated with the faulty new query. As a result, every 5 minutes there was a chance of either a good or a bad set of configuration files being generated and rapidly propagated across the network. Once the update had actually propagated out to the rest of the cluster, then the outage basically stabilized stabilized for being broken effectively. Every request to Cloudflare takes a well-defined path through our network. These requests first terminate at our HTTP and TLS layer, then flow into our core proxy system, which we call FL for frontline. This is going to be relevant later, and finally through Pingora, which performs cache lookups or fetches data from the origin if needed. As a performance transits the core proxy, we run various security and performance products available in our network. This is done through a module-based system, and one of those modules, the bot management, was the source of today's outage. This is basically a machine learning model that we use to generate bot scores for every request traversing our network. Our customers use bot scores to control which bots are allowed to access their sites or not. So, do you want to allow bot traffic? Do you not want to? If you do, what kind of bots do you want to allow? It's supposed to identify the kind of bots trying to hit your site. The model takes as input a feature configuration file. A feature in this context is an individual trait used by the machine learning model to make a prediction about whether the request was automated or not. This file is regenerated every few minutes and then propagated out to the network. This allows us to react to new types of bots and new bot attacks, so it's critical that it's rolled out frequently and rapidly as bad actors change their tactics quickly. This is a totally reasonable way to handle the problem. The issue is when something goes wrong, it propagates out to the network very quickly. A change in our underlying ClickHouse query behavior, explained below, we'll get to that generates this file, caused it to have a large number of duplicate feature rows. This changed the size of the previously fixed size feature configuration file, causing the bots module to trigger an error. Unrelated to this incident, we are currently migrating our customer traffic to a new version of our proxy service internally known as FL2. This is a new version of FL, frontline from earlier. Both versions were affected by the issue, although the impact observed was different. Customers deployed on the new FL2 proxy engine observed HTTP 5XX errors. Customers on the old proxy engine known as FL did not see errors, but bot scores were not generated correctly, resulting in all traffic receiving a bot score of 0. Customers that had rules deployed to block bots would have seen large numbers of false positives. So in this case with the older version, it wasn't crashing, but it was still blocking users if they were trying to block bot traffic. The customers who were not using a bot score in their rules did not see any impact, so if you weren't trying to mitigate bot activity and you are on the old version of FL, then you could have connected to that site. During all this, Cloudflare's status page also went down. The status page is hosted completely off Cloudflare's infrastructure with no dependencies on Cloudflare. This was a coincidence, but it did leave them to think, oh, we were being attacked. Why is both the status page and the main system, which are not deployed together, both going out? Likely what happened to the status page actually was a DDoS, not a malicious one, but users who are having issue with Cloudflare all trying to access the status page and overloading the infrastructure. At its very core, this was an outage caused by a faulty update to an SQL query. But we don't blame SQL for a developer writing a bad query. Also, blaming SQL doesn't generate the clicks. For context, it's helpful to know how ClickHouse distributed queries work. A ClickHouse cluster consists of many shards, basically collections of the data. To query data from all shards, we have so-called distributed tables powered by the table engine Distributed. I'm sure an engineer named this one. In a database called Default. Again, I'm sure an engineer named this one. The distributed engine queries underlying tables in a database R0. The underlying tables are where data is stored on each shard of a ClickHouse cluster. Before today, ClickHouse users would only see the tables in the default database when querying table metadata from ClickHouse system tables such as system.tables or system.columns. Since users already have implicit access to the underlying tables in R0, we made a change at 11.05 to make this access explicit, so that users can see the metadata of these tables as well. By making sure that all distributed subqueries can run under the initial user, query limits and access grants can be evaluated in a more fine-grained manner, avoiding one bad subquery from a user affecting others. Unfortunately, there were assumptions made in the past that the list of columns returned by a query like this would only include the default database. Note how the query does not filter in the database name, with us gradually rolling out the explicit grants to users of a ClickHouse cluster. After the change at 11.05, the query above this one right here started returning duplicates of columns because those were for underlying tables stored in the R0 database. And unfortunately, this was the type of query that was performed by the bot management feature file generation logic to construct each input feature for the file mentioned at the beginning of this section. As part of the additional permissions that were granted to the user, the response now contained all the metadata of the R0 schema, effectively more than doubling the rows in the response, ultimately affecting the number of rows in the final file output. Basically, the database was updated to give the user more access to the data available inside, giving them access to more of the metadata. But the query was not updated to properly handle this, and when this happened, it effectively doubled the size of the output from the query. Now here we have the Rust part. Each module running on our proxy service has a number of limits in place to avoid unbounded memory consumption and to pre-allocate memory as a performance optimization. In this specific instance, the bot management system has a limit on the number of machine learning features that can be used at runtime. Currently, that limit is set to 200, well above our approximately 60 features. When the bad file with more than 200 features was propagated to our servers, this limit was hit, resulting in the system panicking. This is the block of code that caused that to happen. And again, this was in FL2, not FL1. Both were causing problems. FL2 was panicking. FL1, if users were trying to block bots, everything was being marked as a bot. Now, everyone with Rust experience knows exactly what is happening here. The key part to look at is the unwrap at the end. Basically, what this is saying is extract the value if the value is okay. If not, panic. Kill the application. And you know what? Rust is doing exactly what it is told to do here. We have a database query that exceeded the pre-allocated memory. So Rust says this is clearly incorrect. You want me to crash? Okay, I'll crash. This is not being caused by an undocumented error. This is not being caused by Rust misbehaving. This is a developer that said, if the value is bad, don't do anything with the value, immediately crash the application. In Rust circles, there is a lot of discourse about unwrap, but the general best practice is to avoid it in production, as just crashing usually isn't the best course of action. It is fine in like a quick and dirty script. You don't really care about the value. If it crashes, you're the one passing values in. You know what the data is going to be. It doesn't really matter. It's kind of like doing a blind typecast where in your own quick and dirty script, it doesn't really matter. But in production, you want to handle that error. You probably want to do something in a state where you're getting invalid data. Maybe you want to go and try again. Maybe you want to go and report an error to the user. Usually in production, you don't just want to crash. To make this a lot more clear, some users suggest renaming unwrap to something like unwrap or panic to make its function a lot clearer. Very importantly here, there is a Rust linter known as Clippy. It's kind of the main Rust linter. And linters basically aim to catch common mistakes that developers make. It's an automated way to catch these mistakes. And Clippy can catch this mistake. This is something you can tell it to do. This is not a failure on Rust. Rust provides all of the tools to handle this correctly. Clippy is going to tell you if you handle this incorrectly, this falls squarely on the developer, or very possibly Cloudflare allowing vibe coding. I don't actually know who wrote the code, and I don't think we're ever going to know. And this is a complete failure on Cloudflare's part to properly enforce the use of linting and enforce proper development practices. This is not the kind of issue that Rust is trying to solve. This is a dev that told Rust to crash if there is an error. It crashed because it was told to do so. And I'd argue this is not even the fault of the rewrite, as the old version still wasn't allowing traffic through. It was just setting the bot score to 0, and then anyone who was blocking bots were just being blocked. So it still created the same result of users not being able to access the service. It's just, in one case, everything was crashing. In the other case, everyone was being marked as a bot and automatically blocked. Rust does not and has never sold itself on solving every single fault. This is basically trying to solve the halting problem, which is probably impossible. We don't know how to solve the halting problem. It's a little bit difficult. What it does try to do is enforce type safety and memory safety at the compiler level, forcing you to know if a function is going to return an error, rather than just guessing based on the documentation. And in this case, even if it was documented, it would have said how much data is supposed to be returned, and that was clearly outdated in this case. memory safety does not mean that you can't mismanage memory allocation. What it does mean is when you do, you are going to find out very, very quickly. I'll leave the full Cloudflare blog post linked in the description down below, and hopefully we don't have to do this again. It's totally fine if you don't like Rust, right? Like, don't like what you don't want to like. But if you're gonna hate something, please understand what you actually hate. Because if you start criticizing something for something it didn't do, all you do is look like a moron and ruin any credibility you possibly had left. Anyway, I expect to see some fun replies on this one. I know most of you are, normal people, and if you don't know what's going on, are willing to actually learn what's going on. I know it's a very small number of people who really want Rust to be this evil thing. I don't know what to tell you. Anyway, if you liked the video, go like the video. If you really liked the video, go subscribe. And if you really, really, really like the video and you want to become one of these amazing people over here, check out the Patreon, subscribe to Daily Bearer Pay, linked in the description down below. That's going to be it for me. I was not planning to make this video, and I want to go do something else now.